Okay, now that we've practiced just the process of factoring, now we can actually solve. And remember, when you solve a quadratic, what you're solving for are called the zeros or the roots. It's where the quadratic equation touches the x-axis. So every time you say x is equal and there are two x's, this is what you're looking for. Where do they touch the x-axis? All right, so the first method is the square root method, and that's when you have, normally you have an ax squared plus a bx plus a c is equal to 0. Notice an x to the first power and x to the second power. When you're using the square root method, and you can use that anytime when there's only a squared term. Notice right here, you have negative 3x squared is equal to 60. There is no x to the first power, so we can take the square root of an x squared. So the first thing you're going to do is divide both sides by negative 3. So now you have x squared is equal to negative 20. Ooh, this is going to look weird, because when you take a square root, but remember, normally you cannot take the square root of a negative number, but with quadratics, sometimes you're going to have imaginary answers, imaginary terms called complex. So when we take the square root of the left, and on the right, we're going to rewrite negative 20 as negative 1. We're going to put a plus and minus right there. Well, the square root of negative 1 is I. And then 20 we're going to write as 4 times 5. And notice we could have written 2 times 10, but neither one of those are perfect squares. 4 is a perfect square. And that's the whole point to doing it this way. The square root of 4 is 2, and then a 2 comes out. And the only thing that's left, so x is equal to both negative 2i, and technically you'd probably want to write it like this, 2 root 5, and then put the I, and x is equal to positive 2 root 5, because those two are the coefficients, and there's the I. So that is the square root method. When there's only an x to the second or a k to the second, whatever the variable is, right? Now we have a trinomial. I'm going to go ahead and write that. I'm going to put a 1 there. That helps you. Be sure and do that. You don't have to, though. So now, if you have 3 terms and the leading coefficient is that invisible 1, you can go directly to a double set of parentheses. And remember, we're going to graph this. Oh, by the way, since the x there equaled, it had an I in it, that means that graph was probably up here someplace. Or, since it was a negative graph, possibly looking like this. When I is part of the answer, it will not touch. The roots will not touch the x-axis. All right, so we're going to take factors of 30 that add up to negative 1, and factors of x squared, so x and x. Factors of 30, so like negative 30 and 1, negative 15 and 2, negative 10 and 3, negative 6, 5. So x, when you add negative 6 and positive 5, you get negative 1. But we factored, now we have to solve. So using the zero property, you could do this. Set the zero property says that a number times 0 is equal to 0, or 0 times a number is equal to 0. So what that means in terms of quadratics is if we let this whole thing right here equal 0, then this 0 times that entire parentheses will equal 0. Or if we set the second parentheses equal to 0, then this 0 times this expression will equal 0. All right? So for this one right here, we'll just add 6. So x is equal to 6 for this one. Subtract 5, so x equals -5. The other way that I've shown you before is you can just use kind of intuitive. What will zero out -6? 6. What zeroes out +5? -5. And if I said, I would like you to show me a general sketch of that graph, well, we know it's going to touch down there at -30, and over here at -5, and over here at +6. Well, -30 is probably still way down there someplace, but that graph is going to be doing something like that. Because remember, the x's mean they're the roots, or where they touch the x-axis. All right, that is it for this one.